Today's lesson is on word problems and covers pages 144 and 145. Now, because this lesson is on word problems, I will not actually go through the whole question probably to solve it, but I will start to break things down for you and you can finish solving them on your own. The first question says that there is a valley that is 300 meters below sea level, and the top of the mountain, so the valley is created by the edge of the mountain, is 2,000 meters above sea level. So if we were to look at this, right, we'd have here's our valley, and here is the top of our mountain. Now, sea level would be kind of this line of where the ocean typically is. And so what they're saying is that the bottom of the valley is 300 meters below, and the top of the mountain is 2,000 meters above this blue sea level line. So there are two people that have different ideas. Brooke says that the total height of the mountain, so the distance going from the top of the mountain to the bottom of the valley peak, she says that it's 2,300 meters, and Vita says that it's 1,700 meters. So your job is to decide who is right and explain why they are right. Part B tells you about Mount Lam Lam. And so Mount Lam Lam is the tallest mountain in the world from below sea level. If you go to its very base at the bottom, which would be under the ocean floor. And so the top is 406 meters above sea level, so above the blue line, and the bottom is 10,911 meters below sea level, so below the blue line. So they're asking you to calculate how tall is this mountain all together, from the very top to the very bottom. Question 2 asks you to range the temperatures from coldest to hottest. So you're just going to rewrite them in a list, and the first one should be the coldest, and the last one should be the hottest. And you'll remember from your own real life experience this year, right? Minus 40 is a lot colder than minus 2, right? And plus 25 is a lot warmer than plus 10. So you kind of will probably logically know that sequence of what's the coldest and then work your way up to what's the hottest. Question 3 will give you a few different scenarios. So if the temperature is 15 degrees, what would happen if it increases 20 degrees? So increase is going to be our code word for we are adding. So if we are starting at 15 degrees and then we're increasing by 20 degrees, then you would find the answer. For question D, when it switches to decreasing, that is going to be our code for subtracting. So we'll still start with 15 degrees and then it's going to decrease 10 degrees. So that will help you find the answer. Question 4 is going to ask you which temperature is furthest from negative 3 degrees Celsius. So I'll just go through A with you. Sometimes it can be easier to approach this question by creating your own number line. So we'll find that negative 3 is here. So we have to say, is it further away from negative 5 or positive 5? And you can probably tell just by looking that positive 5 is quite a bit farther away. But if you needed, you could count the steps, right? So this is 2 away, and this is 1, 2, 3, 4, 5, 6, 7, 8 away. So 5 degrees is farther. Question 5 asks you to draw a number line from negative 10 to positive 10 and mark a number that is, and then they give you several different cases. So I've just chosen a few of them to give you an idea of how each one works. So 2 less than 0. So less than means we're going to move to the left. So 2 less than 0 is negative 2. So I'm going to write above negative 2 the letter that is attached to the description. So then I'm going to look at C. 3 greater than negative 1. So I'll find negative 1 and I want to go 3 greater. So I'm going to go to the right. 1, 2, 3. So that will put me at positive 2. So I'll label that C. So greater than, we move to the right. E is halfway between, oh, and I forgot to write the two numbers here, positive 2 and positive 6. So if I look at positive 2 and positive 6, halfway between is positive 4. So I'll mark that and label it E. H is a little bit trickier because we need to be twice as far away from 0 as we are from negative 4. So we can't quite find a space in the middle that's twice as far, because this would be equal distance if we went with negative 2. And if we move a little bit closer to 4, there's 3 spaces to 0, but 1 to 4, so it's actually 3 times as far. Instead, we have to look on the outside. We have to go past it. So if we find that this is 4 away, between 0 and 4, to get twice as far, we need to go another 4. So that would take us to negative 8. So if we mark negative 8 as H, it is 8 away from 0, and it is 4 away from negative 4, and 8 is twice as much as 4. Question 6 is kind of an algebra question, but they're using shapes to show you. So when they use the same shape, it means they want you to put the same integer in 3 times. So what one number could you add 3 times to get negative 6? Or what one number, so this is going to be different from the one that goes in the square, what one number could you add 3 times in order to get negative 30? So I would think about what a third of each of these numbers is, but then keep in mind that what sign do you need to use with it, right? If you're adding positives, you'll get a positive. If you're adding negatives, you'll probably get a negative. Question 7 is a puzzle where each row, so rows go side to side, column, so columns go up and down, and diagonal, so we're going to go kitty corner, adds up to positive 3. So we need to fill in all of the missing boxes using this information. Now, there's 2 boxes we could try to fill in first. We could fill in this box or this box because there's only one missing piece of information in that row. So if we were to look here, minus 2 plus positive 5 is positive 3. So that means that 0 would go into this box because it's already positive 3. In order to figure out what goes in the center box, positive 5 plus negative 3 is positive 2. In order to get to positive 3, we would need to add 1. So positive 1 will go in the center. Now, if you're looking for the next box to fill in, we use our diagonal. So we would fill in this box because we could look at minus 2 plus positive 1 and then see what else we need to add in order to get to positive 3. Question 8 is going to give you a chart that contains cities, their average winter temperature, and their average summer temperature. They're going to ask you to calculate the range. So the range is how many degrees it changes throughout the year. So basically, what is the distance between negative 5 and positive 20? So in order to find that, you could say 20 minus negative 5 is positive 25, right? You could also look at the distance model here, right? And go, okay, to get from negative 5 to 0 is 5 degrees. To get from 0 to 20 is 20 degrees. So together that's 25. So whatever way works for you, but you're calculating the distance between their average lowest and their average highest temperature. Question 9 is going to give you a chart of the average temperature on 5 different planets. And they're going to get you to do some different things with it. For question A, they ask you to write the temperature in order from least to greatest. So least would be the coldest temperature, and greatest would be the hottest temperature. Question B says, what is the difference between the highest and the lowest average temperature? Difference is the answer to a subtraction question, so we'll be subtracting the highest number and subtracting the lowest from the highest number, and that will give us the difference. Question C asks, which planet has an average temperature 200 degrees lower than that of Earth? So if we're going for lower, that means we'll be subtracting, so you could take Earth minus 200, and the answer should be close to one of the other planets' average temperature. Question 10 has a plane taking off, and the temperature on the ground is 10 degrees Celsius. The temperature outside the plane decreases by 5 degrees for every 1,000 meters it climbs above the ground. So that's why I kind of showed here's 1,000 meters. Once it goes up that much, it subtracts 5 degrees. So at 1,000 meters, it would be 5 degrees Celsius. Question A is going to ask what the temperature would be at 3,000 meters. So we go up another 1,000, means we subtract another 5 degrees. That would give us 2,000. And then if we went up one more 1,000, we'd subtract another group of 5 degrees, and that should give you that temperature. Question B is going to ask you the temperature when it's 3,400 meters above. Now, 400 is not a group of 1,000, but it is going to be part of a group. So if we had 1,000 meters here, and it takes up 5 degrees, we could try separating that into 5 groups. So if we separate that into 5 chunks, oh, that's 4 chunks, pretend these are all even, each of these would go up 1 degree. And by the end, it would have gone up 5 degrees. Now, we'd have to take 1,000 and chop it into 5 pieces. So if you divide 1,000 by 5, it gives you 200. So every 200 meters, it goes up 1 degree. So you can use this to calculate how much higher 3,400 the temperature, or how much lower the temperature is going to be than with 3,000. I'm going to let you see if you're able to solve questions 11, 12, and 13 on your own and figure out what operations you need to use. The one note that I will make about question 13 is that it's asking how much the temperature changes in a day. So you're looking for the distance between your low and your high for each day, which could be like a high minus low would give you that distance or the temperature change. Remember to fill out the Google form after this assignment, and if you need help with these questions, feel free to reach out and we can set up a Zoom session to go over it.